I'm not really an Agile coach. I'm rather a software quality assurance engineer, so I'm coding on daily basis, coding tests, but also a production code. So I've been working, I'm working for Luxoft, or actually for UBS through Luxoft. And I've been working there for 6 years right now, and I think that the environment that we are working in is fairly mature Agile environment, and this whole talk is based on the experience that I gathered there. So today I will try to convince you that it is possible to use classical test management tools to inspire yourself to become more agile. How we can do it, we'll see in a moment. So first, maybe a few words about the context, so you just understand a bit more my background and know a bit more about where these things that I will be talking about are possibly applicable. So I think that there are two most important questions that we need to ask ourselves in order to decide what are the quality assurance practices that we will apply to our products. And the first one, I think the most important, is how important it is for you to actually be able to respond to changing environment. Right? That's the first one. And the second one is how expensive your product is. And the reason why I think this is important is that if you are given yes answer to the first question, meaning it is important to respond quickly, and your product is expensive, then there is a high probability that you will want to use the practices that I will be talking about. And right now I need to define what is actually a fast response and what is a expensive product. So Jeff, a few hours ago, was talking about responses in terms of hours or minutes, while I think that actually anything below a week, but what I mean is that requirement came, you've done some development, you've done some testing, or actually all testing that needs to be done, and then you're able to deploy it to production. So if this whole process is shorter than a week, it's fairly fast. That's one thing. And the other, what does it mean that the product is expensive? So I think that anything above tens of person years, right? So if, for example, you have 20, 30 person years of effort in the product, that's fairly expensive. So anything above that I would say that that's a product that you would probably like to use some rather QA practices than QC practices. Okay. So first, let's think about the tools that we surely need to create software. I mean, we can hardly get rid of them. So first one is a tool to manage your requirements, right? So requirements basically compose a problem space, describe the problem space that we have, and we need to have a tool to manage it. That's sure. That's for sure. We also need to create a solution. Since we are in software development business, solution is usually a piece of a code, so we want to store it somewhere as well, right? So we need to have a source code repository to store the code. So that's the second tool. Whatever you're using, I just picked here some examples like Rally or Git, but it doesn't really matter. Conceptually, these are the types of the tools that you need. And the third one is that, okay, I have the solution, but somehow I need to deliver the solution to the customer, right? So usually right now, it's, as Jeff also mentioned, it's done using a CI/CD tools like Jenkins, for example, right, that you have a pipeline, and at the end of the pipeline, you have a build delivered to prod, done. Or you do not have this build triggered manually, but as Jeff said, you have it totally automated, and then you have a continuous deployment. Anyway, these are the three types of tools that we certainly need in order to deliver the software. And yet, sometimes we say that we need another set of tools that are tailored for tests specifically. And I asked the question why we need these tools. I asked it on a couple of forums. I asked it on a Test Warriors conference last year, and these are the answers that I've received. So we want to plan and track then preparation of test cases. We've prepared the test cases, so then we want to plan to execute them, right? We've executed them, okay, fair enough. So there are some defects related to this execution, so we want to have a tool to manage these defects. We also want to gather a various metrics out of it, which is a traceability metrics, right? So we want to understand what are the test cases that test each particular requirement, or what lines of code are covered, or branches of code are covered, you know, this kind of thing. And since we are living in the dynamic environment, so when I say that it's over, let's say, 20, 30 person years of effort, it's usually that there are a couple of tens of people working on a product, which means that this product is changing pretty dynamically. So I need to have also a way to learn, right? So there are aspects of my product that I don't really know, because basically when I'm working in my team, which is 5 people, there are 45 other people doing constantly changes to the code. So every week I have 45 person weeks of changes in my code, which is nearly a person a year. So there is a huge amount of knowledge that I just don't have, and I have no way to have it, right? Because it's changing so dynamically. So what they say is that I also want to use the test cases as a way to teach myself, and also teach to learn and teach others, other new joiners, right? Okay, it seems reasonable. However, let's just try to deep dive into each of these aspects. Planning. So I think introducing the tools to plan your test efforts and track test execution can be harmful in 2 ways. One is more psychological one, and the other is more pragmatic one. So let's first talk about the psychological one. Okay, Agile has been with us for over or almost 20 years, right? We all know that responding to changes quickly is the most important thing. But how? I mean, what Agile actually changed in our environments so it is possible to respond to changes quickly? And if I were to give an answer to this question and just name one single thing, I would say that the most important thing that Agile actually did is it removed barriers. It removed barriers between testers and developers, but also between engineers and business, between service providers and client, and lately between the, let's say, people who are creating the software and people who are deploying the software to the customer, meaning all this DevOps movement, right? So the only thing that we're doing here actually is removing barriers. And the reason why we do it is just that whenever we have a fence in our process and we're just throwing things over the fence, we always encourage the behavior of the, you know, we will just have this well-known ping pong game, right? When we just push the product or sub-product over the fence, saying, okay, it's good enough, and the other part says, oh no, it's not good enough, it works for me, and you know, we start this ping pong game, which we don't really want, because we don't want to lose, we just cannot afford to lose our time. And introducing these tools to manage your test efforts, which actually implies that you have some other tools to manage your dev efforts, creates this mental barrier in your team. And that's an issue, because you create the fence, and we are then pushing things back and forth, which we don't really want. Okay, but maybe you can say that, oh no, in my environment, actually, even though we have these tools, everyone understands it. We have a floating roles, right? So a person who is a QA in one sprint might be a dev in the other sprint. That's okay, and we all have this understanding that it should not really create the barriers. It's just tailored. It is more optimal. Okay. So then there is the other. Problem with these tools is that they create a false, or they are silent assumptions that are false, right? Which is, we assume that if I've done 70% of test cases, it means that I've spent 70% of my time, which is obviously a false assumption. We don't really know how much time it will take to actually perform the remaining 30%. It may take the same amount of time or even more. We don't know that. We don't know what are the defects that I will find there. Who knows that, right? How much time it will take to fix these defects? I don't know. How much time it will take to retest them? I don't know. Right? Which means that practically using these tools for tracking is meaningless. I mean, it just creates an illusion of control. It does not give you anything. And the question right now is, okay, so how can I do better? What can I change? And actually, the Agile Manifesto itself gives us the answer, right? That there is the point saying that I don't really care about comprehensive documentation. What I care about is only the working software, the working solution, right? That's the only thing I care about. And here we have the shift, and that's actually what Jeff was talking about. I was smiling a lot during Jeff's talk because it was like, this talk so much resonates with what I want to say. Because the thing is that I don't really care how much test cases you've performed and how much are left to be done. No, what I care about is whether the feature is delivered to the customer or not, whether the customer is happy or not. That's what I care about, right? So the idea is to actually embed and entangle the testing effort with the dev effort, and we probably, I don't know, how many of you actually heard about the 4C method in terms of the defining architecture of the software? Okay, one person. So basically, the 4C, going from the top to bottom, is that we need to think about context, which is our application is usually not by itself, but it is integrated with other applications, right? So there is a certain context that we work in. Then we have the level of container, which is my application itself. Then in the container, in the application, we have components, and then in the components we have classes, usually, right? So these are the 4 levels of architecture, and they actually correspond to 4 types of tests that we also need to incorporate and or create. And the thing is that as a developer, it's been, come on, guys, it's been 20 years since TDD was invented, right? And thankfully, along this time, BDD also appeared, and what Marcin was presented just a while ago, CDC, right? So these are the 3 techniques that we just have in our tool belts. And while TDD is okay for covering this class level or component level, it's not that good on the container level or above at the context level. It's just hardly applicable. However, a few years ago, BDD appeared, right? Behavior-driven development, with lots of frameworks to support the business-driven automation testing, right? And we are at the container level, and for a long time it was okay. But even in my environment, still we have, unfortunately, that's the thing that I was fighting with, but we have a separate UAT test team. Because in the bank, I'm working in a bank, there is a front office, middle office, back office. In each of these offices, there are multiple applications. And actually, the flow of starting from the let's say user to the back of the bank goes through tens of applications. And the issue was, okay, how to test it? Should I really be deploying all these applications in some test environment and then test it this way? You know, you can imagine how expensive it is and how brittle the environment would be. But this is exactly where the CDC actually steps in, right? So suddenly, I have an automated tool to automate tests on the context level, right? So these are the ways that I can entangle the test effort with dev effort and actually track only the features that are done. And by doing a feature, I mean a feature is done only if a set of tests on each appropriate level is delivered together with the production code, right? So that's the point here. And if I do it this way, then the reports, actually, I just get them for free, right? I don't really need to prepare any reports. The only thing I'm doing is just that I commit my changes that contain all the tests that I've just created a test that covered the newly created code, right? It's just that all these tests are being run, including all new tests, including the regression test suite. And then the most important thing that Jenkins actually gives us, or any other CI/CD tool, is a simple answer, which is either green or red. I do not really need to analyze anything, right? So that's actually the best report we can get. You can either merge it to the master or you cannot, right? So the point here is that if you automate your test efforts, you just get it for free. You just have test reports. You don't need to care about it anymore. Another thing that we want to measure is how effective or how efficient our test suite is. And first is the question, what does it mean that a test suite is efficient? And I again asked this question, and the answer I got is that a good test suite is one that finds many defects. That's a good test. It means that it's efficient, right? It makes sense then. And I so strongly disagree with this statement. I mean, for me, the efficient test suite is one that prevents defects from appearing. This is what an efficient test suite is. And what does it mean? It means that when I'm changing a code, adding, of course, new tests, and I run the build locally, if it fails, then okay. I mean, I've either made a mistake in my production code or I need to amend my test code so it reflects the reality, right? So this way I'm actually preventing from introducing the defect. I'm able to fix it right away, and that's it. That's how it should be, right? So I'm actually preventing from defects to appear and not then controlling whether it appeared. I mean, if it appeared, then look, fair enough. But then much more important thing is for me to change the process in such a way that actually it does not reappear or similar defects do not reappear. And fixing the defect, of course, you need to do it. But that's a second thing. Okay, all this traceability matrix. Gosh, it was once in my career that I was asked to create the traceability matrix, and it was the worst assignment I ever get. I mean, it's dull, right? It's really boring exercise. And the problem with traceability matrix, which is like which test which requirements, right, is that these documents are outdated the moment you created them. It just doesn't make sense to create these. I mean, we cannot afford not to automate it. Which is cannot. It doesn't make sense to do it any other way. And there is such an easy way to do it. I mean, the only thing you need to do is this requirement management tools. Each one actually gives you a unique ID, and a unique ID for the requirement. So the only thing you need to do is tag your commit with a message starting with the ID. And that's it, right? And since I store all my test cases, all my tests in the code repository, together with the production code, I immediately have a link between test, code, and the requirement. So I immediately know what tests are run or cover which requirement and what code is being tested, just like that, right? As simple as that. And of course, when it comes to the line of code or branch coverages, there are automated tools to do it. I do not have time right now, 5-10 minutes left, okay. We can talk about the, during the break, what are the goals that we could set up there in the coverage tools, right? Whether it's 100%, above 100%, but how much then, right? So there are a couple of things that you can just think of. Okay, another aspect, learning, right, and future reuse. Again, the problem with any written documentation is that it gets outdated. The moment you create a test case, a week from now or a couple of weeks from now, it will be outdated. Just that's the way it is. And here, the BDD comes with the rescue, right? We have there are a couple of frameworks. In my environment, we use JBehave in one project and a homebrew framework in the other one. But conceptually, it is all the same. So basically we are taking a look at our application from the business perspective using business API only, right? There is no way that you will like reach to the database and just check whether the database changed somehow, right? No. If you need to change, if you need to check something, then you need to design an API to actually get the information from the application. And we have a really nice story of adding such API to our application. And at the very beginning, it was only for testing purpose. I mean, it was just simple REST API that was added only for testing purpose. But then it actually occurred that business guys who were then operating or maintaining this application also found it very useful. So the bottom line here is that whatever you need in tests, you will probably need it also in production, right? If you need some API to get some information and it is useful for tests, there is most possibly a use case, a production use case for it as well. And one of the lessons that we've learned with using JBehave, I don't know whether you know it, but the idea basically is that you are able to create a test case using a natural language, right? So you just write down a statements that anyone can understand, anyone from your business domain, of course, can understand, and can see exactly how your application will behave, because there is just a set of examples how it will behave, and these examples are executable. However, the issue that we found with this approach is that whenever you have only examples, it is really, really, really hard to actually get the business context out of it, because then somehow you need to cache all these examples in head and find the business rules from this example, based on these examples, which actually doesn't make much sense and is really difficult. So what we've started adding is the narrative part. And one can say that, okay, but you're adding a narrative part, and then this narrative part can also be outdated. And I agree, yes, it can be outdated. It does outdate. However, the big advantage of this narrative part over any Confluence page or Jira or whatever you're using is that if the example in the one given story file fails and you need to change it, then you precisely know what is the chapter in the documentation that you need to read in order to ensure that it is still consistent, right? So you change the example, and then you have only this bit that we need to actually make sure that this is consistent. You do not need to go and look for anywhere on the Confluence page or Jira or whatsoever. You are at the place, and you just need to ensure that it is really consistent. That's it. So yes, it does require some discipline, but also it allows you really to learn efficiently just by reading these tests, right? They are really, really readable. Okay, and the last but not least, certainly, is the defect management. So Jeff actually said a pretty nice thing, saying that there are no defects right now. And I totally agree with it. I mean, honestly speaking, there are two ways how defect can appear only, which is, first, let's imagine a situation. I'm working on some feature, and my last exploratory session that I'm doing when the whole feature is ready found something, right? There is a defect. And now here's the first decision point that team needs to make, which is, are we okay with it, or we feel ashamed of it? If we feel ashamed, then okay, we will fix it. If we're okay with it, fine. So that's the second decision point. We call our product owner and just ask the guy, okay, are you okay with this? That's how the feature works. But here's the limitation that we found. Is it okay to go on production or not? How do you think? And then, again, two answers, right? Either it is okay, and in such case, we just take the limitation and log it as a yet another feature, yet another backlog item, and prioritize it against other backlog items that we have in the backlog, right? Or it is not okay, and then we just need to fix it. Either way, no defect is logged till now, right? And the one thing the one and only source of truth when it comes to defects is production. And this is really what we found is useful. Is just that whenever a defect comes from production, okay, let's log it as a defect, because this is actually shows us how efficient our quality gates are, right? So then we really want to mark it, because I want to see over time if my practices that I've added to assure my quality actually pays back or not, right? So currently, it's for last quarter we had like 2 production defects, so not that much, and I think it's a really good achievement, really good one. So, and still, when we found a defect, the most important thing is, okay, it's a production defect, so the most important thing is actually to fix the production as soon as possible. However, the other effort is taken to change the process, right? To just think a while, okay, what happened? Why did we introduce it? How can we improve in order for it not to reappear? And sometimes the simple situation is that, okay, so let's just add a test and let's just see other repositories whether we have similar defects, and that's it. That's how it might turn out. And the other disadvantage of defect management tools that I found is that, unfortunately, sometimes they are used as a communication tool, which is totally a shame, right? Because it looks like that. I'm just logging a defect, and I just got a response from developer. You've tested it the wrong way. It works for me. Thank you. And just, oh no, it's just I've did these steps. You can recreate it yourself. No, but you have a wrong configuration. No, I have a good configuration. It's just that's what it is. Oh yeah, but your test environment is wrongly configured. It should be like that. And then it just goes, right? Like back and forth, and that's the issue, right? Because it takes huge amount of time if you're using these tools as a communication tool. It is much easier to just sit down together and just work it out together, right? And then eventually, eventually in the defect management tool, you can just put a quick summary how it was fixed, and maybe what if you're going to use it, what corrective actions you've applied if you want to use it only. Okay, so a conclusion. I don't really want you to come back to your environments and say, okay, we need to just get rid of these test management tools because they are evil. And the reason why I don't want you to do it is that maybe in your context, in your environments, at the particular, when your teams are on particular, let's say, maturity level, they need them, maybe, right? It's just like, you know, when you break your leg, you use the sticks to actually help yourself to walk, and that's okay. If you are at this condition, that's okay to have them. The only thing that we need to realize is that they constrain us at some moment, right? That if we come to a point that our leg is healthy again, it is perfectly fine to just get rid of the sticks and try to walk, right? Because it is really hard to walk fast and run with these sticks in hand, right? And this is exactly how the test management tools can inspire us to find suboptimal things in our environments. Thank you very much.